Statistics is science and art of handling the aggregates of facts, observing, enumeration, recording, classifying, and otherwise systematically treating them is known as statistics. Okay, what is statistics? We get it. Then the word statistic has been used to convey different meaning in a singular and the plural sense. In singular sense, it means the science of statistical methods comprising of theory and techniques used for collecting, analyzing, and drawing the inference from the numerical data. In the plural sense, it means the numerical set of data. According to the professor Hoya Serist, okay, just underline that. Scientists may define as the aggregate of facts affected to market extent by multiplicity of causes numerically expressed, enumerated or estimated according to a reasonable standard of accuracy, collecting in a systematic manner for a predetermined purpose and planned in relations to each other. It's very simple. Statistics. We just want to understood what is statistics in the basic format. There exists a one word type of questions or anything that more questions are related to the upcoming area. So just study what is statistics. Then moving to the classification of statistics. Okay, the science of statistics may be studied under the following heads: inductive statistics and descriptive statistics. First is inductive statistics. It involves drawing drastically valid conclusions about the totality of a given population on the basis of a sample. Sampling theory falls under its purview. Then the descriptive statistics. It involves describing some characteristics of a numerical data, measures of central tendency, dispersion, skewness, moments, correlation, etc. fall under this purview. These are discussed. So these are the differences between inductive statistics and the descriptive statistics. Just memorize what are the topics or the characteristics of descriptive statistics, and those are fall under this descriptive statistics, that are measures of central tendency, dispersion, skewness, moment, correlation, etc. So in this chapter we will discuss what is statistics, measures of central tendency, measures of dispersion, skewness, moments, kurtosis, correlation, index number. One by one we will discuss all the topics, then moving on to the topic wise previous year question paper discussion. Okay, next topic, the measures of central tendency. What is it? Measures of central tendency. It's very easy. One of the one of the most important objective of statistical analysis one of the most important objective of statistical analysis is to get one single value that describes the characteristics of the entire data. This value is called the central value or the average central value. What is central tendency? Central tendency, the central value or the average value is called the central tendency. Central value or average value is called the central tendency. This value is the point around which all other values of the data cluster. Therefore, it is known as the measure of central tendency. According to the Crosstown and the Coward, an average value is a single value within the range of the data that is used to represent all the values in the series. An average value is a single value within the range of data that is used to represent all the values in the series. Since the average is somewhere within the range of data, it is sometimes called the measures of the central value. Sometimes called the measures of the central value. Okay. Essentials of a good average. Next topic is essentials of good average. Good average എന്ന് പറയുമ്പോൾ അതിന് വേണ്ട essentials. The average, good average. Clearly and statistically defined. While defining a central tendency or average, it should be noted that it is clear and stable. It must be rigidly defined and not left to mere estimation of the observer. Next point, easily understood. It should be easily understood. The average should possess simple and obvious properties. It should be easy to understand for the layman also. Based on all values. Average must be based upon all the values in a given distribution. If the item is not based on all the value, it might not be the representative of the entire grouped data. Minimum impact on the sampling change. Minimum impact on the sampling change. To make a comparison of two or more distribution, we have to find the representative values of this distribution. These representative values are found within the help of measures of central tendency. No or least impact should be shown on the sampling changes. Minimum impact on the sampling changes. Another point, algebraic and arithmetic representation. It should be capable of being calculated with reasonable care and rapidity. It should be capable of further algebraic as well as arithmetic calculation. Not affected by the extreme observation. Measures of central tendency should not be affected by extreme observation. By extreme observation, we mean a very small or very large observation. There are 1, 2, 3, 4, 5, 6 points are mentioned. You just note down the important points that is clearly and substantially defined and easily understood, and based on all values, minimum impact on the sampling change, algebraic and arithmetic representation, not affected by the extreme observations. These are the important points. Not affected by the extreme values. Easy to understand based on all values, minimum impact on sampling change. Next topic we are going to discuss about the various measures of central tendency. 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 Measures of central tendency can be divided into mathematical averages or position related averages. Mathematical averages, arithmetic mean, geometric mean, harmonic mean. Position related averages mean median. Median mode and position related averages. Mathematical averages, what are they? Arithmetic mean, geometric mean, and the harmonic mean. Position related averages are median and the mode. And then we are going to discuss about what is mathematical averages. These are computed with the help of arithmetic and algebraic methods. The value of these averages does not necessarily lie in the series. The important averages of the categories are discussed ahead. But in the mathematical averages in the important point, the value of this average does not necessarily lie in this series. Important point you should mention in this mathematical averages, the value of this average does not necessarily lie in the series. Now, arithmetic mean, mathematical average can be divided into three means, that is arithmetic mean, then geometric mean, then harmonic mean. First one is arithmetic mean. It represents the entire data by one value, which is obtained by adding together all the values and dividing this total by the number of observation. That is total number of observation divided by number of observation. Arithmetic mean is the sum of all observations divided by the total number of observation. Uses of arithmetic mean. Then we are going to discuss about the uses of arithmetic mean. It is used to summarize the large scale data. It is used to summarize the large scale data as it is difficult to understand the raw data. It is used to facilitate the comparison and the comparative study. Okay, comparison and the comparative study. Next point, average gives such values which becomes the guideline for the decision making. Averages become very important when it is decided to establish a relationship between different groups. Next, the properties of arithmetic mean. This section, the mathematical averages section, is very important because we want to memorize the each point one by one, because the uses, the properties of arithmetic mean, that all are necessary for our exam pattern, because the small points are very important. So try to memorize and read as much as possible. Okay. The properties of arithmetic mean. The sum of derivatives of the observations from their arithmetic mean is always zero. The product of arithmetic mean and the number of values on which the mean is based is equal to the sum of all values. N x bar is equal to sigma x. We can also return as x bar is equal to sigma x divided by n. That is total number of observations. Sum of total number of observation divided by the number of observation. It is affected by both change in origin and change in origin and change in scale. The sum of squares of derivation of a set of values is the minimum when taken from the mean. Sum of squares of the deviation of a set of values is minimum when taken from the mean. That is an important point. Important point. Types of arithmetic mean. Then we are going to discuss about the types of arithmetic mean. Simple arithmetic mean. Simple arithmetic mean all items of the series are taken as equal importance. Can be divided in individual, discrete, and the continuous. Simple types of arithmetic mean. Arithmetic mean can be divided into simple arithmetic mean. In simple arithmetic mean, all items of the series are taken as equal importance. It can be calculated individual, discrete, and continuous series. For individual series is the one in which items are listed separately and each item appears as an individual unit. It is also referred to as ungrouped data. That is not a grouped data, ungrouped data. It's not a grouped data, ungrouped data. Ungrouped data. The arithmetic mean of the arithmetic mean by the direct method. The sum of all observation arithmetic mean of the series can be computed by following methods: direct method, shortcut method, step deviation method. Direct method, arithmetic mean by direct method, sum of all observation in the series divided by the total number of observation. Sigma x is equal to sum of all observation x1 plus x2 plus x3 etc. n the number of observation. Then the shortcut method. The shortcut method is used where the number of observations are large to avoid the difficulty in the calculation of arithmetic mean. The given formula is used to compute the arithmetic mean by this method. X bar is equal to a plus sigma d divided by n. X bar, the arithmetic mean, a the assumed mean, sigma d the sum of deviations of the items from the assumed mean, x minus a, n the number of items. step deviation method. A direct method, shortcut method, step deviation method. This method is an extension of the shortcut method. This method is not applicable to all problems. It can be only used when the values of the series differ by a constant value, a plus sigma d dash divided by n into I. That is not so much important. So give the importance to the equations, formulas, and all that. For the discrete series, we discuss about the individual series. Then we are going to discuss about the discrete series. For the computation of arithmetic mean in discrete series, the value of the variables are multiplied by the respective frequency. The number of observations is equal to the total number of frequencies. Number of observations is equal to total number of frequency. The formula for computing arithmetic mean by direct, shortcut, and step mediation method are follows. Direct method, how to find the value of arithmetic mean, and first one we are going to discuss. In a discrete series, the frequency of the each row is multiplied by its respective value. The total is then divided by the total number of frequencies to find out the arithmetic mean. X bar is equal to sigma xi divided by sigma f. X bar, the arithmetic mean, sigma f, sum of the frequency, sigma fx, the sum of product of the values of the variable and their corresponding frequencies. Then in the shortcut method, in this method, the deviations of the items are assumed, mean are multiplied. Here the formula is x bar is equal to a plus sigma f dx divided by sigma f, sum of the product of deviation from the assumed mean and the respective frequencies, sigma f, sum of the frequencies. The explanations are given. Next to the step deviation method, there is also a formula for the continuous series. In a continuous series, the arithmetic mean may be calculated by taking into consideration the midpoint of the various classes. Direct method, the following formula can be used for the calculation of arithmetic mean in a continuous series by the direct method: sigma fm divided by f. Continuous series, arithmetic mean, midpoint, lower. How to find the midpoint? Lower limit plus upper limit divided by 2. It's a direct method, continuous series, so there exists a lower limit and upper limit. Then to find the midpoint, we have to add the lower limit and upper limit and divided by 2. We got the midpoint. Then sigma f into m. M is the mid value. Sum of the values of the midpoint multiplied by the respective frequencies of the each classes, then divided by the total frequency, sum of the frequencies. Then the shortcut method also here, and also the step deviation. I just want to memorize these formulas for the application level questions. And next topic, we are going to discuss about the weighted arithmetic mean. What is weighted arithmetic mean? This mean is calculated when all items of the series are not equally important. In this mean, items are accorded different ways depending on their relative importance in the series. It is the mean of the weighted items of the series. Given formula is used to calculate the weighted arithmetic mean. Weighted arithmetic mean can be represented x bar w. X bar w, sigma x into xw divided by the sigma w. Here x into w, w is the weight. The xw, the sum of product of items multiplied by their respective weight, and the sigma w is the sum of the weights. The next one is the combined arithmetic mean. It is the common mean of the two or more series. It can be calculated when the mean values and the number of observations of the two or more series are known. The combined arithmetic mean is calculated on the given formula. Just memorize this important formula. Combined arithmetic mean: x bar c n1 x1 bar plus n2 x2 bar plus n3 x3 bar divided by n1 plus n2 plus n3. N1 is the x bar is the combined arithmetic mean, and here given that where x bar is the combined arithmetic mean, x1 x2 x1 bar x2 bar x3 bar, the arithmetic mean of first, second, and the third group, n1 n2 n3, the number of items in the first, second, and the third group. So this is the topic. Next day we discuss about the geometric mean and its properties. So day by day we can analyze the each and every topics very clearly. Stay with me. Thank you for watching. Please support and stay with me. Okay.